Hello there and welcome to the GCSE revision video. Here we're looking at problem solving with quadratics. Quite a difficult topic this one, so be prepared for some challenging questions. Okay, so a quadratic equation is an equation of the form something times x squared plus maybe something times x plus maybe a plus or minus some number equals 0. Equals 0 being important that it's on one of the sides. So for example, something like 3x squared minus 7x plus 2. Here, a is referring to the number 3, b is referring to the number minus 7, so that minus 7 there belongs to the whole b term, and c is equal to 2. Could look like this, where it's just a single 1x squared, so here a is representing the number 1, b is representing the number 9, c is representing the number minus 3. That minus 3 belongs to the c term. It could have no x term, so it could have an x squared, but no x and a plus c. So in this case here, a is equal to 1. The b term effectively is 0 because there's no standard x's in this equation, and c is equal to minus 7. It could have no c term, so this one has a standard x squared term, so a is 1. It has an x term, so that's b equals 8, and we have no c term here. There's no number added on in the end, but all of these are still quadratic equations. And the final one might have a negative in front of the x squared term, and it might be in a different order as well. So here, a is still going to be the number in front of the x squared, minus 1. b is still going to be the term in front of x, 5, and c is still going to be the number on its own, 7. So even though it's in a different order, the order doesn't matter, it's what's going in front of the different terms, either x squared, x, or just a number on its own. Okay, so at some point in these questions you have to, you might have algebraic terms on either side of the equal sign. The best way to solve a quadratic equation is to move everything onto one side by adding or subtracting it, leaving nothing behind. So that's why there's 0 on the other side of the equal sign. This is important, you've got to remember this, so write this down now. It's the quadratic formula, and it refers to these letters here, a, b, and c. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. You don't get that in the formula booklet, so it's something you need to remember. And in these types of questions, will come in all shapes and sizes. You have to be fully prepared with your full toolbox of mathematical skills in order to solve these questions. All the time, what you're looking to do is turn the algebra into something times x squared plus something x plus some number maybe, or minuses equals 0. So that's our target the whole way through these questions. Alright then, so let's get stuck into the first question then. Pause the video and have a go at this one. Okay, so in this question here, the important starting point is the area of a trapezium, and hopefully you've remembered the formula for the area of a trapezium. The area of a trapezium is half a plus b, so a plus b over 2 times h. Okay, so that's the two parallel sides, a and b, times by the height. Okay, so in this case here, this length here is going to be a. This length here is going to be b, two parallel lengths. This side here is going to be the h, and now we can just use the formula. So let's use all of these values into the formula. So it's going to be x plus 5 plus the b term, which is x plus 8, all over 2 times by the height, and the height is x. And we're also told in the question that the area of this trapezium is 42. Okay, let's just tidy this up a little bit before we move on to the next thing we need to do. 2x plus 13 over 2 times by x equals 42. I think the first thing we need to do here probably is to times both sides by 2. We're trying to turn it into this expression here, where there's no fractions involved at all. So times everything by 2. So that's going to become brackets 2x plus 3 times x equals 84. The next thing we'll do is we'll expand the brackets. 2x squared plus 3x so 13x, so it's 13 from before, equals 84. And then take away 84 from both sides, 2x squared plus 13x minus 84 equals 0. And there we are. Okay, so that's the answer to part A. Now we have to move on to part B. Calculate the perimeter of the trapezium. Okay, well, we need to know all of these dimensions, and we also need to know this dimension extra as well, so there might be some extra calculations there. It looks like it's a diagonal, so maybe Pythagoras might be involved. So let's use our quadratic formula. So x equals minus b, so that's going to be minus 13, plus or minus the square root of b squared, that's 13 squared, minus 4 times a times c, all over 2a, so that's going to be 2 times 2 is 4. Now, just to highlight, the c term here is minus 84. So into your calculator must go the term minus 84. Don't use the subtract button, use the minus button underneath the fraction button. So I'm now going to type all of this into my calculator all in one go. Sorry you can't see it, but this is what I'm doing. So minus 4 times 2 times minus 84 all over 4. That gives us an answer of 4. And if I was to use the negative solution, because it is plus or minus, I get minus 21 over 2. Now the length of the sides here is obviously not going to be a negative number, so I can just ignore that one. So I now know that x is 4, so that means this side here must be 9, this side here must be 12, this side here must be 4, and this side here, well, I don't know what that is. I'll have to maybe make a little Pythagoras triangle. I know I've got 4 on this side here. I know that that side's 9 and this side's 12, so the difference of that is 3. So it's going to be 3, 4. I know the Pythagorean triple there. It's 3, 4, 5 in that right angled triangle. So it's going to be 5. The answer for P is 5 plus 9 plus 4 plus 12 equals, grab a calculator, let the calculator do all the hard work here, equals 30. Lovely, and that's all in centimetres. So the perimeter of this shape here is 30, and we've used the quadratic formula to help us work that out. Alright then, so as I say, quite challenging questions, these ones. Let's pause the video and have a go at this next question. Okay, so we have a diagram here of a playground. The playground is extended by adding 10 more meters on its width. So that's going to be 10 more meters on its width. So that would be plus 10. And 20 more meters onto its length. So it's going to be out like that bit there. So that's going to be plus 20 in this direction. The area of the rectangle playground is double the original area of the playground. Okay. So the original area is going to be 3x squared. Now we need to work out these. The area of the larger playground is double the area of the previous playground. Okay, so now we could probably work out these extra bits and then the area will have doubled. So if we work out these extra bits now, this area here is going to be 30x. This area here is going to be 10 times 20, that's 200. And this area here is going to be 20 times x, so that would be 20x. So if this area here has now been doubled to make the bigger rectangle, then it must be this area is equal to the extra parts for it to have then doubled. So what I can say here is that 3x squared is equal to 20x plus 30x plus 200. Now I'll simplify this a little bit. That'd be 50x now. And I'm turning it into this expression here. That's always my target. So I'll now need to take everything onto the same side. 3x squared minus 50x minus 200 equals 0. And there we are, that's the answer to this question. We've shown that 3x squared minus 50x minus 200 is equal to 0. And how we've done that is we've shown that the original area gets doubled to the bigger rectangle area, so therefore this original area must be equivalent to this extra area if it's now doubled. Okay. Alright, so let's move on to the next question. Pause the video and have a go at this one. Okay, so the area of the square ABCD is 10 centimeters squared. Show that x squared plus 6x equals 1. Okay, so the way we could work out this whole square is if we work out each of the 4 quadrants. So 3 by 3, that's 9. So this area here, you can multiply the terms on the outside. 3 times 3 is 9. Because it's a rectangle, you can do that. 3 times x, that's 3x. 3 times x again is 3x. And then x times x is x squared. So we know that the total area of that square is equal to 10. Let's take away the 9 onto the other side. And there we are, we have our answer. We've subtracted 9 from this line to this line. And we set up the original line by working out all the individual areas and setting it equal to 10. Okay. Alright, let's move on to the next one. A little bit tricky here. Pause the video and give this one a go. Right, okay, let's get started in this question then. So the width of the rectangle is x, the length of the diagonal on the rectangle is 12, the perimeter of the rectangle is 28. Okay, so the whole thing around is going to be 28. Find the possible values for x. Okay, well what I think I'm going to do is I think this question is calling out to use Pythagoras' theorem. So what I need is for a term to be equivalent to this length here. Now if I know my whole perimeter is going to be 28, then that's going to be 2x, and then plus 2 lots of these top and bottom terms will equal 28. Well, therefore each length and width combination is going to be 14 because I have 2 lengths and widths. So therefore this length here is going to be 14 minus x. And you can see if I was to add up all of these sides now, you would get 28. So I had to half the 28 because I've got one length up here that will be 14 minus x and one length down here that will be 14 minus x, and the total there will be 28. So now I'm just going to apply Pythagoras' theorem. A squared plus b squared equals c squared. So it's going to be 14 minus x squared plus x squared equals 12 squared. So what I'm going to do here is I'm going to have to now expand 14 minus x squared properly. Now the only way you should be thinking about expanding a double bracket is and expanding a squared bracket is by thinking of it as a double bracket where you're timesing the bracket by itself. So 14 squared is 196. That would just be 196 minus 14x minus 14x plus x squared. So that's going to be x squared minus 28x, simplifying the two 14s, plus 196 plus x squared equals 144. Let's simplify this now. 2x squared minus 28x plus 196 equals 144. We're looking to work out the possible values of x, so I now need to subtract 144 onto the other side. So that's now going to be 2x squared minus 28x. 196 take away 144 is 52. Let's half everything now. Might as well make the question a bit easier for us. Half of 52 is 26. Okay, and now this needs solving, so I'll pull out my quadratic formula. It's going to be minus b, but b's already a minus number, so that will now be 14, plus or minus the square root of b squared, that's 14 squared, minus 4 times 2 times so not times 2, times 1 in this case, because a is 1, times c is 26 over 2 times a, so that'll just be over 2. So you can't see it, but I'm now typing this away into the quadratic, so into my calculator. So it's be 14 squared minus 4 times 1 times 26 all over 2, and that's going to give me, to correct 3 significant figures, 11.8, and the minus solution is going to be 2.20. Okay, so both of those there are correct to 3 significant figures. So there we are, that's the answer to this question. Okay, let's move on to the next one. Pause the video. It's a trapezium one again, so we can do these ones. Pause the video and have a go at this question. Okay, so once again, the area of a trapezium formula is a plus b divided by 2 times h. So we're now just going to apply those lengths into the formula and work out that we have 2x squared minus x minus 120 equal to 0. So the area of the trapezium is going to be a, which is x plus 6, plus b, which is 3x minus 4, all over 2, times by the height, which is x minus 1, equals, and the area of this trapezium is 119. Okay, let's simplify what we've got. So we've got inside the bracket 4x squared plus 2 over 2 times x minus 1 equals 119. Let's now divide the inside of this bracket here by 2, so simplifying again, that's going to be 2x squared plus 1 times x minus 1 equals 119. Let's now expand the brackets, because that's what you do when you're timesing brackets together. So why is that an x squared? That shouldn't be an x squared at all, just x. So expanding the brackets now, so it's going to be 2x times x, which is 2x squared. 2x times minus 1, that's minus 2x. 1 times x, that's plus x. Next one's going to be, 3, yeah, that's fine. 1 times minus 1 is minus 1, equals 119. Let's simplify what we've got here. 2x squared minus x minus 1 equals 119. Let's now take away 119 onto the other side. Get 2x squared minus x minus 120 equals 0. Lovely. Good stuff. We now need to find the value of x, so let's now use the quadratic formula. It's going to be minus b, and b is already negative, so it would be 1 plus or minus the square root of b squared, that's 1 squared, minus 4 times 2 times minus 120, all over 2a, so that's 2 times 2. So I'm typing this into the calculators now, so it's 1 plus 1 squared minus 4 times 2 times minus 120, all over 4, that's going to be 8, and otherwise it could be a negative value. Let's do the minus 7.5, no, we don't really want that value, so find the value of x, the answer is 8. It would be 7.5 minus 7.5 if you use the minus solution on that quadratic formula, but we don't have negative lengths on a trapezium. So x equals 8. Alright, let's move on to the next question. Pause the video and give this one a go. Okay, so in this diagram we have a diagonal of length 8, we have one side of length x, and we have a perimeter of 20. So that must mean that all 4 of these sides must add together to make 20. Let's split it up into a length and width pair, so that each length and width pair will equal 10, because we've got 2 of them. So therefore this length over here is going to be 10 minus x. Now we're going to use Pythagoras' theorem to set it equal to 8 squared. So Pythagoras triangle here. So it's going to be a squared plus b squared equals c squared. So a is going to be x squared. B is going to be 10 minus x all squared equals 8 squared. Now the only way you should be squaring a bracket is considering it as a double bracket. 10 minus x times itself, because when you square things you times them by itself, so it's good to think of this as a double bracket question. So it's going to be 100 minus 2x plus x squared, so 20x, because you've got two lots of minus 10x. So it's going to be x squared plus 100 minus 20x plus x squared equals 64. Let's now tidy up. 2x squared minus 20x plus 100 equals 64. Let's take away the 64 onto the other side. So 100 take away 64 is 36. 2x squared minus 20x plus 36 equals 0. We can now half everything, so x squared minus 10x plus 18 equals 0. And there we are, we're at the final answer here. Okay, moving on to part B, solve and put your answer to three significant figures. So this here we'll need to use the quadratic formula, so x equals minus b, but b is already a minus number, so it's plus 10, plus or minus the square root of b squared minus 4 times 1 times 18, all over 2 times a, so that's equal to 2. So typing this all into the calculator now, 10 plus square root of 10 squared minus 4 times 1 times 18, and then divide that by 2, and be an answer of 7.65 to three significant figures, or the minus solution is going to be 2.35. And there we are. So it says here, give your solutions. So because that's a plural, I'm expecting there to be two solutions to this equation. So 7.65 or 2.35. Alright, let's move on to the next question. Pause the video and give this one a go. Okay, so Ivan is a shot putter. The formula h equals 2 plus 6t minus 5t squared gives a height h of the shot above the ground after t seconds after the shot is released. Solve. Give your solutions correct to three significant figures. Okay, so 2 plus 6t minus 5t squared equals 0. So you could just leave everything alone. What I think I'm going to do is, because the t squared here is negative, I'm going to move it on to the other side. So it's going to be 5t squared, I'm going to move it onto the other side. Let's move everything else with it. So it would be take away 6t, and it would be take away 2 equals 0. So just made the t squared positive by moving everything onto the right. Let's now use the quadratic formula. X equals minus b. So that's already a value of minus 6, that's now plus 6, plus or minus the square root of 36, that's 6 squared, minus 4 times a times b, so 4 times a times c, all over 2a, so it's going to be over 10. So grab the calculator now, it's going to be 6 plus the square root of 36 minus 4 times 5 times negative 2. So use the negative number button there, over 10, and that's going to equal, first solution will be 1.472, and the next solution will be have the negative value there, that's going to be minus 0.272. Each to three significant figures, so I can scribble out that 2 there, but I'll need all the figures there. Okay, so give your solutions. Yep, so that's what we've done. We've 2 solutions there. Moving on to the next one. The shot hits the ground after t seconds. Write down the value of t, giving your answer to 3 significant figures. Well, in this case here, if h is equal to this expression here, what we've just done here is effectively solve the equation when the height is equal to 0. And that's when it hits the ground. So, if the shot put has just hit the ground, it's got a height of 0, so it's going to be one of our 2 solutions here because we've just solved the equation when it equals 0. It must go forward, the time, so the value for t must go forward in time, so therefore the answer to part II is 1.47 seconds because it goes forward in time. The negative solution value would be effectively if you were to imagine it going backwards and it would hit the ground here. So it's 1.47 seconds in time. Alright, let's move on to the next question then. Pause the video and give this question a go. Okay, so a stone is thrown vertically upwards from point O. The height above O of the stone t seconds after it is thrown from O is h meters, where h is equal to this equation. Show that the value of t when the height of the stone above O is 12 meters. So I want to solve the equation when the height is equal to 12 meters. Now what I might get here is I might get 2 solutions. If this is my point O and the stone gets thrown upwards and then downwards, when it's at a height of 12, it might have 2 points in time at which the stone is 12 meters above the ground. So we've had to set the height equal to 12. And now what we'll do, oops, there's a t there. Now what we'll need to do is we'll need to solve this equation. This is a quadratic equation. We've got t squared, we've got t, and we've got a number. But to solve quadratic equations, we need everything to be on the same side. Now the t squared is a negative value here, so my preference would be to move that onto the other side, take away the 17t as well, and leave the positive 12 alone. So now I'm going to use the quadratic formula. T equals, because that's the letter I'm using, minus b, so that's 17, plus or minus the square root of b squared, that's 17 squared, minus 4 times a times c, over 2 times a. So grabbing my calculator and typing this all in, 17 plus the square root of 17 squared minus 4 times 5 times 12 all over 10. And that's going to give me a nice answer, 2.4. And hopefully a negative solution as well, so go into the formula, change the plus to a minus 1. So therefore it hits this point here after 1 second, and it hits this point here after 2.4 seconds. Work out the values of t, yeah, so we've worked out the values of t there, 2.4 and 1. Alright, let's move on to the next question. Pause the video and give this question a go. Okay, so a simple Pythagoras one here. Eventually we want to work out the area, so we'll have to do base times height divided by 2, but we need to work out the value of the base and the height. So, nice little Pythagoras question. A squared plus b squared equals c squared. So that's going to be x plus 2 squared plus 2x plus 7 squared equals x plus 14 squared. Okay, so all of these things need to be squared. We need to be super careful about that. The way you square a bracket is you times the bracket by itself. That's how you square anything. You times it by itself, especially when it's brackets. So the first one is going to be x squared plus 4x plus 4 when that all gets simplified. Plus, and then the 2x plus 7 squared. So the way you do that is you expand the double bracket of 2x plus 7, 2x plus 7. So it's going to be 4x squared, and that would be 14 plus another 14, so that would be 28. and 7 times 7 is 49. So it's 4x squared plus 28x plus 49. And on the other side it's going to be x plus 14 squared. So that's going to be x plus 14 times x plus 14. So that's going to give us x squared plus 28x plus 14 squared is 196. X squared plus 28x plus 196. Okay, so now we've got our equation that we now need simplifying. So what I think I'm going to do first, I can see there's 28x on both sides, so I'll subtract both sides by 28x. Let's now subtract an x squared from both sides as well, so that will cancel out on both sides. Let's now just do a little bit of tidying, so it'd be 4x squared plus 4x plus 53 equals 196. Take away 196 onto the other side, and you get minus 143. Okay, so the next thing we now need to do is use the quadratic formula. So that's going to be x equals minus 4 plus or minus the square root of 16 minus 4 times a times c over 2a. So therefore x is going to equal, open up the fraction, minus 4 plus the square root of 16, take away 4 times minus 143 over 16, and that's going to equal, well, 11 over 4, or in other words 2.75. And the negative solution, if we go into the equation and change the plus for a minus, is minus 3.25. So we can basically ignore that one because we don't have negative lengths on a triangle. So this length here is now going to be 4.75, because that's 2 more than 2.75. And then for this length here, it's going to be 2 times 2.75 add 7. So that's going to be 12.5. So now the area is going to be base times height divided by 2, 4.75 times by the width, 12.5 over 2. So grab the calculator and let the calculator do the work here. 4.75 times 12.5, divide that by 2. And we get an answer of, what's the answer going to be? Work out the value of A. It's going to be 29.6875. Or as a fraction, it's going to be 475 over 16. I'd probably leave both of them there. And it's going to be centimetres squared. Okay, so there we are. That's the answer to this question here. A little bit of Pythagoras and then working out the area of a triangle. Okay, so let's move on to the next question. Pause the video and have a go at this one. Okay, so a rectangle lawn has length 3x and 2x on the lengths and widths. The lawn has a path of 1 metre on 3 sides, so a path around the side, around the left, top and right hand side. The total area of the lawn and the path is 100 metres squared. Show that 6x squared, blah 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 blah. Okay, so what we need to work out the area of then is the total lawn and patio region. So, in the horizontal axis, it's going to be 1 on the side, 1 on the other side, and 3x in the middle, so that's going to be 3x plus 2. Going up the side, it's going to be 2x plus an extra 1, so that's going to be 2x plus 1. And the area of a rectangle is just base times height. So here, the area is going to be equal to 3x plus 2, 2x plus 1. Which is also equal to 100. We're told that it equals 100. The total area of the lawn and the path is 100 metres squared. So let's now expand the brackets. So it's going to be 6x squared plus 3x plus 4x plus 2 equals 100. So that's going to give us 6x squared plus 7x. Take away the 100 on the other side, so that'll be down to minus 98 equals 0. And there we are, that's our answer to part A. Moving on to part B now, calculate the area of the lawn. So that's just going to be the 3x by 2x. So what we need to do is we need to solve for x. So we're going to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c, that would be minus 98. All over 2a, that would be 2 times 6. So you can't see it, but I'm now typing it away into the calculator. Negative 7 plus the square root of 49 minus 4 times 6 times minus 98, all over 12, and that gives me 3.5. And if I have the negative solution, I'll probably get a negative answer, yeah, that'd be minus 14 over 3. No matter what it is, it's negative and it won't be a dimension on a real life problem. Okay, so now we are tasked with working out the area of the lawn. So the lawn area is just going to be 6x squared, so 6 times 3.5 squared. So 3.5 times 3.5 times 6 equals 73.5 meters squared, because it's an area. Okay, there we are, that's the answer to that question. Okay, moving on to the next one. Pause the video and have a go at this one. Okay, so we are asked to work out the area of the trapezium. It equals 17. Okay, so remember the area of a trapezium has a formula a plus b divided by 2 times by h. A and b are both of the parallel sides, and then h is the height of the trapezium. So, therefore, the answer is going to be x plus 7 over 2, and then that will be multiplied by h, which is 2x. And that will equal 17. Okay, so let's tidy this up a little bit. It's going to be 2x plus 7 over 2 multiplied by 2x equals 17. Now what I can do here is I can cancel out this divide by 2 and this multiply by 2 in the left-hand expression, which will leave me with 2x plus 7 multiplied by x equals 17. So therefore, if I now open up the brackets, it's going to be 2x squared plus 7x equals 17. And then if I take away 17 from both sides, I get the final answer. Good. Work out the value of x given your answer to 3 significant figures. So this is going to be the quadratic formula part of the question. X equals minus 7 plus or minus the square root of 49, take away 4 times a times c, that would be minus 17, all over 2a, that would be 4. So you can't see it, but I'm now typing this away into the calculator. Minus 7 plus the square root of 49, take away 4 times 2 times negative 17 over 4. And to 3 significant figures, the first answer is 1.65. And let's see if we do get a second answer. Change the plus for a minus, and we get minus 5.15. That's definitely not going to be a dimension on a trapezium, so therefore it's just 1.65. Okay, let's move on to the next question. Pause the video and have a go at this one. Okay, so let's have a look at this question here. We want to show that ABCD is a trapezium. Now, just a reminder, this is what a trapezium might look like. And what's important about a trapezium is that if you have a look at this pair of angles here, you can see that if you were to go this way, then this way, then this way, you've effectively done a U-turn. U-turn from here to here. That means that you've turned 180 degrees around, so that means these two angles must add up to 180. And the same will be true for these two angles here, must add up to 180. So we need to show that two of these angles that are next to each other add up to 180. Now we also know that the angles inside a quadrilateral will add together to make 360. So let's do that bit first. X squared minus 105 plus x squared minus 65 plus 470 minus 30x plus 510 minus 30x equals 360. It's quite a lot, so it's going to be 2x squared. Let's look at the x terms. That's going to be minus 30 and minus 30, so that would be minus 60. The numbers are going to be minus 105 plus 470 minus 65, I missed that one out, plus 510, that's going to equal 810. 810 equals 360. Let's now take away 360 from both sides. So 810 take away 360 gives us 450. We could probably make this question a little bit easier by now dividing by 2. So 450 divided by 2 gives us 225. And is that... so let's now factorize. It's 15, isn't it? So it's x minus 15, x minus 15. I just somehow recognise that 225 is 15 squared, and therefore the sum of the roots is going to be minus 30. You could use the quadratic formula there as well. Okay, so x is definitely 15 in this question, no doubt about that, because we've got it twice. Let's now work out what all the angles are going to be. Well, angle A is going to be 15 squared minus 105, which makes that 120. Let's just check that. 15 squared minus 105, yeah, 120. Angle B is going to be 15 squared minus 65. So it's going to be 40 bigger than the previous one, so that's 160. Angle C is going to be 470, take away 30 lots of 15. So 470 minus 30 times 15 on the calculator, let's not make any mistakes, 20. And D is going to be 510 minus 30 lots of 15. 510 minus 30 lots of 15 equals 60. Lovely, and there we are. So it looks like B and C will match up to make 180 degrees, and A and D will match up to make 180 degrees. So it's definitely going to be a trapezium. So it's going to be something like A, B, C, D. Pairs of angles in a trapezium sum to 180. Okay, there we are, that's the answer to that question. So pretty difficult one, that one. You had to make your quadratic, solve it, and then put your answers in for A, B, C, and D, and spot you get a trapezium out again. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so we've got this question here. Now I'm thinking we've got a couple of ways of doing this. We can either work out the whole rectangle by going all the way up there and down, or we can somehow try and split it in half somehow, so maybe across like that. I think I'm going to give this one a go. I'm going to go area A and area B. If you've done the whole thing, take away the smallest square, we should end up at the same answer. So, area A. Area A is going to be the difficult one to work out. The B area will be slightly easier. So if I want to work out this height here, I know the width. I need to work out the height, and I've got a whole height of 3x, and I've got a distance here of x plus 1. So it's going to be 2x, 2x minus 1 for this height here, because then the whole height will be equal to 3x. Okay, so it's going to be 4 lots of 2x minus 1. So it's going to be 8x minus 4. Moving on to area B, that's going to be x plus 1 times 4x minus 3. Expand the brackets, so it'll be 4x squared minus 3x plus 4x minus 3. So therefore the total area, A plus B, is going to equal 4x squared. We'll have 8x minus 3x and plus 4x, that'll be 9x. And we'll have minus 4 and minus 3, so that'll be minus 7. And that will equal 40. Let's take 40 onto the other side by subtracting it. And we get an answer to equal 0, and that's exactly what we're looking for in part A. Moving on to part B, solve the equation to 3 significant figures. So grab your calculator, it's going to be a quadratic formula one. It's going to be minus 9 plus or minus the square root of 81, that's 9 squared, minus 4 times A times C, all over 2A, that would be 8. So you can't see it, but I'm now typing this away into the calculator. Minus 9 plus or minus 81 plus 4 times 4 times 47 all over 8. Also, it's minus 47. Don't lose out that negative. Oh, we get a negative R, so I've put a minus there. Okay, here we are. We've got the final answer now. So it's 2.48. And let's just check if there's any negative solutions. Minus 4.73. No, that won't be an answer for this question. Minus 4.73. No. X needs to be greater than 0. So it's just 2.48. That's the answer to that question. Okay, moving on to the next one. Pause the video and give this one a go. Okay, so in this question I'm looking to work out the area of the shaded region. You could do this in 2 ways. You could work out the whole area first and then take away the rectangle in the middle, or we could split it into chunks and work out each of the different rectangles around the shape that is shaded. I think the easiest thing here to do will be to do the whole shape and then the white rectangle in the middle, and we'll subtract the 2. So the whole shape is going to have dimensions 2x plus 1 multiplied by x plus 3. That's going to be 2x squared minus 3x, no, minus x, sorry, so plus x, plus 6x plus 3. So tidy that up, that would be 2x squared plus 7x plus 3. The little white rectangle, that's just going to be a 2 by 3 rectangle, so that would be 6. So therefore the shaded region will be the difference between these two. So that's going to be 2x squared plus 7x, and then we need to take away 6, so that will now be minus 3. And we're told here that the shaded area equals 45. So let's now take away 45 onto the other side. That would now be minus 48, and there we are. That's our answer to part A. Moving on to part B now, it's a quadratic formula part question. So x equals minus 7 plus or minus the square root of 49 minus 4 times 2 times minus 48 all over 2a, that would be 2 times 2. So you can't see it, but I'm now typing this away into the calculator. So it's going to be 49, take away 4 times 2 times minus 48 over 4, and that's going to give us an answer of 3.45. And the other answer is going to be minus 6.95, but that's not going to be a solution in this question because x needs to be something at least bigger than, well, at least bigger than minus 3 basically. So yeah, that's not going to be a solution. Just 3.45. Okay, let's move on to the next one. Pause the video and give this question a go. And if you're feeling brave enough, try and do it without a calculator. Okay, so what maths are we going to need to bring in here? Well, we know the area of a triangle is equal to 6 root 2, so it must be something to do with area of triangle. Now, this triangle doesn't have a clear base and a clear height with a 2 metre right angle, so we have to use half AB sine C. So, in this case, it's going to be a half times A, we'll call this side A, this side B, and this angle here capital C. It doesn't matter that B is in this corner here, we can call the angle whatever we like. So it's going to be a half times x plus 3 times 2x minus 1 times by sine 45. If you're brave enough, you can work that out on your own. That's going to equal 6 root 2. So let's now expand the brackets and the brackets here. 2x squared minus 6x, so plus 6x, minus x, and then minus 3. And sine 45, we all know that is 1 over root 2. Or root 2 over 2, however you prefer it. Now what I'm going to do next is I'm going to get rid of the half and the 1 over root 2 by multiplying in one whole go by 2 root 2. So I'm multiplying by 2 root 2 here, the 2 for the bottom of the half, and the root 2 for the bottom of the 1 over root 2. That will leave me with just 2x squared plus 5x minus 3. And on the other side it's going to be 6 root 2 times 2 root 2. We've multiplied it onto the other side. Now what's this going to give us? It's going to give us a 12 from the normal numbers multiplying together, but an extra 2 from the root 2 times the root 2 times in together. So it's going to be 12 times another 2, that would be 24. Taking away the 24 onto the other side, I now have minus 27. And now the final thing to do here will be to use the quadratic formula. So that's going to be x equals minus b plus or minus the square root of b squared, that's 25 minus 4 times 2 times minus 27, all over 2a, that's 2 times 2. So you can't see it, but I'm now typing this away into the calculator. Fraction button, 5 plus root, no, root, not square. Ooh, it's all gone wrong. So it's minus 5 plus root 25 minus 4 times 2 times minus 27 over 4 equals, and the first solution is going to be 2.63, and the second solution is going to be minus 5.13. Okay, so the final bit you probably need to do without a calculator, but you could probably get up to here without your calculator. Okay, there we are. So that's the answer to this question. Well, hold on, we probably only need the positive one because we don't want any negative lengths of sides. Okay, let's move on to the next question. Okay, pause the video and give this one a go. Okay, so in this question what we're going to do is we're going to be quite cheeky and we're going to divide this parallelogram into two. Reason being, these are two now congruent triangles that have the same area. So I'm going to work out area A first, and it's going to be exactly the same as area B on the bottom, so I'll just double it afterwards. So therefore the area of this parallelogram is going to be 2 lots of half AB sine C. Obviously the 2 and the half can cancel out straight away, so the answer is going to be 10 minus x, lots of 2x minus 1, times by sine of 150. If you're feeling brave, you can try and do that without a calculator, but I'm not going to. That's going to be, the area of the parallelogram is greater than 15. Okay, so we need to now put a greater than symbol, and it's greater than 15. So let's now expand the brackets. I'm not going to put an equals sign here anymore, I'm just going to put a little arrow just pointing to the next line. So it's going to be 20x minus 2x squared minus 10 plus x, sine 150, that is equal to 1/2, and that's greater than 15. I think the next step I'll do is I'll times everything by 2 just to get rid of this half at the front of the bracket, so it's going to be 20, no, hold on, we've got 20x and 1x at the back, so 21x minus 2x squared minus 10 is greater than 30. And now it looks like we want everything on the side where the pointy bit of the arrow is pointing to. So it looks like we're now going to need to add 2x squared onto the other side. Looks like we're going to need to take away 21x onto the other side and add 10 onto the other side. So it's going to have 0 left behind. We're going to have 2x squared. We're going to take away 21x from this side to the next. And we're going to add 10 onto the other side. So that'll be add 40. So therefore now if we just flip this all around, do a little bit of symmetry, and there we are, that's the answer to this question. And part B would be to solve, but we have not covered solving quadratic inequalities yet. So we're just looking just to do this part of it today. Alright then, a functions question now. So I've typed this one out, pause the video and give this one a go. Okay, so we have functions g and h, and they're defined by x plus 2 and h of x equals x squared. Find the values of x for which h g of x is equal to this expression here. So what I need to do is I need to make the composite function on the left-hand side first. So it's going to be h of the g function. So I do the g function first, I do the function closest to the brackets first, and then after that I'm going to put x plus 2 into the h function. So instead of x, it's going to now be x plus 2, and that's going to go in where x is. So that's going to look like x plus 2 all squared. And we can always expand square brackets by thinking of it as that bracket times itself, so it's x squared plus 4x plus 4. So I want to find when x squared plus 4x plus 4 is equal to 3x squared plus x minus 1. So I now need to solve this equation here. In the first line I worked out what hg of x is, and now I need to solve it equal to 3x squared plus x minus 1. What I think I'll do first, I've got a quadratic equation here, but everything's not on one side, so I'll need to move it onto one side. So what I'm going to do is first I'll take away x squared from both sides. Should I do it all in one? No, I'll do it in mini stages so you can all see what's going on. So I'll take away 1x squared. Then I'll take away 4x. So that's going to be 4 left behind. 2x squared. I have x minus 4x, that's minus 3x. And then take away 4 onto the other side. I have 0 equals 2x squared minus 3x minus 5. I do feel like this factorizes actually. I might give it a go. You can use the quadratic formula here. I'm going to give it a go solving this by factorizing. I think if I put the minus 5 on this side and the plus 1 on this side, then that gives me, expand the brackets, yeah, I get the line above. So here we are then, it's going to be 0 equals 2x minus 5, x plus 1. So therefore this bracket is going to equal x equals 5 over 2, or 2.5. And then this equation here is going to give me a solution of x equals minus 1. So there we are, we get our two answers. And hopefully you got the same if you did it through the quadratic formula. 2.5 and minus 1. Alright then, moving on to the next question. Pause the video and give this one a go. Right then, let's get started on the problem. So we have a right angle triangle here, and we're told the area of the triangle is 27.5 centimeters squared. Now this triangle is a right angle triangle, so we can use the half base times height formula on it because the base and the height meet a right angle. So it's going to be half base times height equals 27.5. Okay, let's substitute in the base and the height values. So it's going to be a half of the base first, that's x plus 4. Times by the height, x minus 2 equals 27.5. Okay, so next thing to do will be to move this half onto the other side, and how do you get rid of a half? Well, you double both sides, so it's going to be x plus 4 to x minus 2 equals, and then let's just make sure on the calculator, 27.5 times 2, 55. Let's open up the brackets now, so it's going to be x squared plus 4x minus 2x minus 8 equals 55. X squared plus 2x, and then we're going to have to do minus 8 to take away 55, so moving this 55 onto the side. Remember, with any quadratic, the way you're going to solve it is if everything's on the same side. That's 63, and then let's see if we can factorize it. I think if we do x plus 9, x minus 7, then that's going to give us the 63 at the back, but then it's also going to give us the 2 in the middle, so therefore x equals minus 9, and x equals 7. So therefore x is the value 7. So work out the length of the shortest side of the triangle. So this side here is going to be 11, this side here is going to be 5. So the shortest length of the triangle is 5 centimeters. Okay, there we are, that's the answer to that question. Let's move on to the next one, pause the video and give this one a go. Okay, so in this question here we need Claire buys some shares for $50x. Later she sells the shares for 600 plus 5x. She makes a profit of x%. Show that this quadratic equation needs to be solved. So, how are we going to get this information into a quadratic equation? Well, the x% represents the increase percentage. Okay, so the way we're going to calculate this is by doing a division of the increase from the starting amount to the final amount divided by the starting amount. Okay, so that's how we're going to work out the percent. Okay, so actually this is going to give us a decimal, so we'll also need to multiply this by 100 to get it into percentage form. So, therefore, x is going to equal the increase from this to this, so that's going to be 600 plus 5x, take away 50x, so that's the increase from this amount here to this amount here, divided by the starting amount, that's 50x. And then we'll multiply this by 100 to turn into a percentage. So let's just tidy this up a little bit. It's going to be 600 minus 45x over, now I'll do here is I'll cancel out 50 from top and bottom, so I'm just left with the times by 2 here, 2x. Okay, what I'll do next is I'll multiply the x onto the other side, so it's now x squared, and I'll multiply the top here by 2, so that's 1200 minus 90x. And let's move everything onto the same side, x squared plus 90x minus 1200. And there we are, that's the answer to that problem. Moving on to the next part. Now, if you couldn't do the first part, you could still actually do part B, because you're given the quadratic equation and all you've got to do is solve it. So you don't need any parts from part A to work out our answer to part B. So let's use the quadratic formula. It's going to be minus 90 plus or minus the square root of 90 squared minus 4 times 1 times minus 1200 all over 2a, so that's going to be 2. So you can't see it, but I'm now typing this into the calculator. Negative 90 plus the square root of 90 squared minus 4 times 1 times negative 1200 all divided by 2. And the first answer there is 11.8, and then the negative answer where it's plus or minus is minus 101, but that wouldn't make any sense. So 11.8 to 3 significant figures. Okay, next question. Pause the video and have a go at this one. Okay, so we've done a few of these now. Remember, the area of a trapezium formula is a half times a plus b multiplied by h, and that's equal to the area. So it's going to be a half. The a and the b value are the two parallel sides, so that's going to be 2x minus 4 add x plus 5, and then we're going to multiply that by the height, which is x plus 3. And that equals the area, which is 60 centimeters squared. So the first thing I'll do is I'll double both sides to get rid of the half and simplify the addition bracket. So it's going to be 3x plus 1, x plus 3 equals 120. Open up the brackets on the left hand side, so 3x squared plus 3 plus 1, so that would be plus 4x. No, sorry, hold on. 9 plus 1, that's 10. And then it's going to be plus 3 equals 120. So therefore 3x squared plus 10x, and then minus 117 equals 0. Perfect, good, that's what we're looking to solve. And then part B is find the value of x. So let's substitute it into the quadratic formula. X equals minus 10 plus or minus the square root of 10 squared minus 4 times 3 times minus 117 all over 2 times 3. So typing it into the calculator now, fractions button, minus 10 plus square root 10 squared minus 4 times 3 times negative 117 all over 6. And that gives me an answer of 4.80. It actually goes 4.7969. So to three significant figures, I look to the fourth one, that's a 6. 6 will round up the 9, but 9 will round up to 10 effectively, so that will mean the 7 has to round up to an 8. So you would still put the three figures there of 4.80. And let's see if there is a negative solution in all this. We get an answer of minus 8.1, so no, that wouldn't make sense as an answer. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here we have a diagram of a circular pond surrounded by a path that's in a grey colour. The constant width of the path is 1.5 metres, and we're told here the extra bit of information that the area of the path is 1/10 the area of the pond. So I think what I'll do is I'll work out the area of both and then work out which one I need to times by 10 to get the other one. So the pond area is just going to be pi r squared. And then the path area is going to be, well, it's going to be a whole thing, take away the circle, so that's going to be r plus 1.5 squared times pi minus pi r squared. So we'll have to simplify the algebra on this a little bit. So remember, r plus 1.5 squared, whenever you square a bracket, you're effectively timesing that bracket by another version of its own self. So it's going to be r squared plus 3r plus 2.25. Let's just double check that in the calculator. 1.5 times 1.5. Yeah, 2.25. So it's going to be r squared plus 3r plus 2.25 all times pi minus pi r squared. Now you can see when I cancel out this and this, I'll just be left with 3r plus 2.25 lots of pi. Okay. So now I need to work out which way we need to multiply by 10. The area of the path is 1/10 the area of the pond. So what I need to do then is I need to do 10 times the path gives me the pond. So 10 multiplied by 3r plus 2.25 times pi equals pi r squared. Now what I can do first, I can cancel out pi's from both sides. I'll expand the brackets with the 10, so it's going to be 30r plus 22.5 equals r squared. Let's double everything so we get them all as whole numbers. 60r plus 45 equals 2r squared. Take everything onto the left hand side, so right hand side now. 2r squared minus 60r minus 45. There's your final answer. Calculate the area of the pond to 3 significant figures. Well, I think what we'll have to do there first is solve this as a quadratic equation. So r is going to equal 60 plus or minus the square root of 60 squared minus 4 times 2 times minus 45 all over 2a, so that'd be 4. So you can't see it, but I'm now typing it into my calculator. 60 plus the square root of 60 squared minus 4, so that's typed in 30 by accident. 60 squared minus 4 times 2 times minus 45, so it's negative 45, over 4. And that gives 30.7. See if there's a negative solution. No, not really. 30.7. So now we need to work out the area of the pond. So now it's going to be, take that 30 squared, 30.7, and square it, and then times it by pi. So the area equals 30.7 squared times by pi. And obviously I'll use my answer button in the calculator for that, to 3 significant figures, 2970 to 3 significant figures, and the unit on that will be meters squared. That'd be the surface area. Lovely, there we are. Pretty tricky question, that one. Well done if you got that right, and hopefully you've learned something if not. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so show that the area a centimeters squared of the quadrilateral PQRS is given by the formula 2x squared minus 18x plus 80. So that's the area of this quadrilateral inside here. I think probably what the best thing to do would be to work out the area of the whole thing and then take away the triangles that are on the outside. So the whole thing, the whole rectangle, the whole ABCD rectangle is 10 times 8. That's 80. Okay, the next thing to do now will be to work out the triangles, so we can just have the quadrilateral left over. So what we'll have to do is we'll have to work out the length from here to here. That's going to be 10 minus x. The length from here to here is going to be 8 minus x. The length from here to here is going to be 10 minus x. And the length from here to here is going to be 8 minus x. So we can see here we're going to have 2 types of triangle. We're going to have this triangle here, and then we're going to have this triangle here. Okay, so for the first smaller triangle, it looks like it's going to be 2 times, so let's write it out. So it's going to be DRS, so the triangle DRS, equals the triangle BPQ equals, so it's half base times height, x times 8 minus x. Okay, and we'll open up the brackets on that, so it's going to be, no we won't open the brackets on it yet, because we've got 2 of them, so for both of them, the answer there is just going to be 2 lots of it, so 8 minus x. So that's going to be the area of 2 of the smaller triangles. Let's now work out the other 2 triangles, so CQR equals SAP equals half base times height, and we're going to need 2 of these, so that's going to be x 10 minus x. So therefore the quadrilateral PQRS is going to equal 80. That's the big rectangle. Take away the 2 smaller triangles and the 2 bigger triangles. Okay, so let's now try and simplify this. It's going to be 80 minus, and then it's going to be minus x times 8 and minus x times minus x, so it's going to be minus 8x, but then plus x squared, because we've got a double negative at the front and then inside the bracket. And then for the second part, it's going to be minus 10x, and then it's going to be minus x times minus x, that would be plus x squared, 1 outside the bracket, 1 negative inside the bracket. So it's going to be 2x squared minus 18x plus 80. And there we are, that's the answer to that question. Okay, next one, pause the video and give this one a go. Okay, so ABDE is a rectangle such that A to B is equal to double B to D. So if we call this line x here, then this side here will be 2x. The area of the rectangle ABDE is s centimeters squared, so that s can be expressed in this form. Okay, so I think what we need to do first is we need to pull out our cosine rule to work out the length of side x. So that's going to be a squared equals b squared plus c squared minus 2bc cos a. Now the only angle inside this is the capital A, so this has to be labelled capital A. We'll label this one B and this one C, and we'll call x the letter A. So it's going to be x squared equals x minus 3 squared plus x minus 2 squared minus 2 times x plus 3, so x minus 3, x minus 2 cos 120. I'm confusing the x's here, aren't I? So in fact what I'll do is I'll change this letter x here to a. So a squared equals. Open up this bracket here and you're going to get x squared minus 6x plus 9. This second bracket is going to be x squared minus 4x plus 4. Okay, let's now sort out the back part. What's cos 120? Cos 120 is minus a half. So the minus half, well the half components, let's write it down. The half components will cancel out the 2 at the front, and the minus components will cancel out with the minus at the front to make it a plus at the front. So it's going to be plus x minus 2 times x minus 3, so it's going to be x squared minus 5x plus 6. So a squared is going to equal 3x squared minus 6x minus 4x is minus 10 minus 15. And then 9 plus 4 plus 6, that's 19. And then the length A is going to be the square root of this. And that's as best we can do, really. The length of side A to B is now going to be 2 lots of this. So that's going to be 2 lots of 3x squared minus 15x plus 19. And now what we can do is we can work out the area of the triangle AB, so the area of the rectangle ABDE is going to be base times height. So the base here is going to be 2 root 3x squared minus 15x plus 19, multiplied by the height, which is 3x squared minus 15x plus 19. And then whenever you've got a square root times by the same square root inside, your answer is just going to be the thing that's inside the bracket. So it's going to be 3x squared minus 15x plus 19. Open up the bracket, times everything by 2, 6x squared minus 30x plus 38. And there we are, that's the answer to this question. Pretty difficult one, that one. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so the sketch shows the curve of y equals x squared plus 4 and the line y equals x plus 10. The line cuts the curve at the points A and B. Find the coordinates of M. Okay, so M is the midpoint. So I need to work out these two coordinates here, and then I can work out the midpoint afterwards. So if I want to find out the intersection of two graphs, what I do is I set the equations of the graph equal to each other. And then I solve. So to solve this, I now need to move everything onto the same side, and then I need to solve it. So it's going to be x minus 3, x plus 2. If I factorise, I could use a quadratic formula, but I think I've spotted it factorised. So therefore x equals 3 and x equals minus 2. Now I need to work out their y coordinates by putting it into any of the two equations, because they should be the same. It'll be 13. And for this one here, it's going to be y equals 8. So this coordinate here is going to be minus 2, 8. And this coordinate here is going to be 3, 13. Now we need to work out the midpoint of these two coordinates. So what's the middle value between the x coordinates? That will be minus 0.5, positive 0.5. It's just ever so slightly on the positive side. And then 8 to 13, well, a shortcut way of working out the midpoint is just to find the average. So 8 plus 13 divided by 2. 8 plus 13 divided by 2, 10.5. Okay, and there we are. That's the answer to this question. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so this question here is a pretty tricky one. Let's just do a quick example with numbers first. So if we say that the ratio of 2 to 4 is equal to the ratio 3 to 6, then you can see what's happening here. They're in the same ratio. The scale factor from one number to the other number is 2, and you could calculate that by doing one term in the ratio divided by the other term in the ratio in the same order. You could do it 2 divided by 4 equals 3 divided by 6, and you would get the same value. So we've got to turn the ratio problem into a fraction problem. So if that helps, pause the video and have another go, but I'm going to now have a go at it. So what I'm going to do is I'm going to do x minus 4 divided by 2x minus 1 equals 2x minus 1 over 16x plus 1. So I've divided the second one by the first one in each of the two ratios. So just as I did with my 2 to 4 to 3 to equals 3 to 6, divided the second one by the first one, I've divided by the second one by the first one here. Okay, so now I need to do a bit of multiplying. So the first thing I'll do is I'll multiply by 2x minus 1 on both sides. And I'll also multiply by 16x minus plus 1 on both sides as well. And that will get rid of my fractions on both sides. So on the left hand side, the 2x minus 1 will cancel out with this 2x minus 1, but I'll also have this 16x plus 1. On the right hand side, the 16x plus 1 will cancel out with what I'm timesing by, but I'll also have 2x minus 1. So 2x minus 1, 2x minus 1. Let's now expand the brackets on both sides. It's going to be 16x squared minus 4 times 16, let's just double check, 64, yeah. 64x plus x minus 4 equals 4x squared minus 2x minus 2x plus 1. Let's now move everything onto the same side, so we'll move it onto the left, so it's going to be 12x squared. This will be minus 63, but then add 4, so that'll be negative. No, wait, hold on. It's going to be minus 63x and then add 4x. So that's going to make it minus 59x. And then with the numbers, it's going to be minus 5 equals 0. I'm pretty sure I might be able to factorise this actually. If I do 12x and then x minus 5, that will get me to minus 60. If I put a 1 in here, then great, I'm there. So my answer is therefore equal to minus 1/12 or 5. Okay, so there we are. You could have used the quadratic formula up at this point here, but I've managed to quickly spot a factorisation, so that was quicker for me. Okay, so there we are. That's how you do these ratio type questions. You consider one part of the ratio divided by the other part of the ratio should be equivalent to the other side of the ratio being divided as well. Okay, moving on to the next question. Pause the video and have a go at this one. Okay, so find the perimeter of the triangle and we know the area. So the area is going to be half base times height, so that's half x times x minus 2 equals 2.5 times the half onto the other side, so it's going to be x minus 2 equals 5. Open up the brackets, x squared minus 2x, and then take away the 5 onto the other side. Now we need to use the quadratic formula on this, so it's going to be x equals 2 plus or minus the square root of 4 minus 4 times 1 times minus 5 all over 2a. So it's going to be 2 plus or minus the square root. Actually, I'll type it all into my calculator all in one go, I reckon. So x equals square root, so fraction button, 2 plus square root 4 minus 4 times 1 times negative 5 all over 2a, so that's 2. So it's going to be 1 plus root 6. I might leave it as that actually. It's a helpful decimal. Yeah, I'll leave it as 1 plus root 6. And 1 minus root 6 will also be the answer, but we don't need that. No other solutions. So now we need to work out the perimeter. So now it's going to be... this value here will be minus 1 plus root 6. Reason being is that I've got 1 plus root 6 take away 2. This side here will be 1 plus root 6. Now I need to work out the other side, so that's going to be a bit of Pythagoras theorem. So it's going to be minus 1 plus root 6 squared plus 1 plus root 6 squared. And let's do that on the calculator. So open up some brackets and type it all in nice and carefully. Minus 1 plus root 6, close the bracket and square it. Plus, open up another bracket, 1 plus root 6, close the bracket and square it. That gives us 14. Okay, so now the perimeter. Oh wait, and you need to square it, don't you? So that'll be the square root of 14. So perimeter is going to equal minus 1 plus root 6 plus 1 plus root 6 plus root 14. So the 1 and minus 1 cancel out, so it would be 2 root 6 plus root 14. But it does say it to 3 significant figures, so I can't leave my answer like this. 2 root 6 plus root 14 gives me an answer of 8.64. Okay, so there we are, that's the answer to that question. Let's move on to the next one, pause the video and give this one a go. Okay, so in this question here we want to find the exact length of A to B and we need to find the coordinates A and B. So, what we need to do, the coordinates A and B are where the two lines intersect, and if we want to find out when two lines intersect, we set the equations equal to each other. And to solve a quadratic equation we have to move everything onto the same side. And then we'll solve it. So it's going to be x minus 2, x minus 4. So it's going to be x equals 2, x equals 4. The y coordinates at these two coordinates are going to be y equals, we'll plug the 2 in and you get 0. Plug the 4 in and you get 4. So it's going to be what is the distance from the coordinate 2, 0 to the coordinate 4, 4. So it's going to be a Pythagoras distance of 2 on the bottom and 4 on this side here. And it says find the exact value of A to B. So it's going to be the square root of 2 squared plus 4 squared. That's the square root of 20 but then we can simplify this as a surd to 2 root 5. So there we are, 2 root 5 is the answer to that question. Okay, final question for you to have a go at now. Pause the video and have a go at this question. Okay, so very similar to the ratio question that we had before, ratios work by there's this common scale factor to get from the first number to the second number. In this case, the ratio is definitely going to be 2. So the ratio to get from here to here is 2. So what we can do is we can divide the second number by the first number and do the same on this side, 2 divided by 1, and we're going to get the same value. It's going to be in the ratio 1 to 2. So therefore, it's going to be, let's now treat this as just a number 2, and we're going to times both sides by x squared. And then I'm going to move everything onto the side where the x squared is, so 2x squared minus 3x minus 5. And let's now solve this quadratic, so it's going to be 2x and x, and I think if I do minus 5 here and a plus 1 here, then that's it factorised. Just double check by expanding, yeah. So therefore x is equal to minus 2.5 and x is equal to, plus 2.5 and minus 1. So there we are, not too bad for a final one there. Probably not the hardest one of the video, but pretty good question nonetheless. So very well done if you've done that, and thank you very much for watching. Hopefully you found this video useful. Hopefully you're working through the set of videos to make sure you've mastered all of the different topics for GCSE maths, and thanks very much for watching.